Hi. So I'm going to talk a bit about Espruino, which is a JavaScript interpreter for microcontrollers and kind of how you might use it. So I guess first off, what's a microcontroller? Well, it's not entirely accurate, but it's just a self-contained computer on a chip. Pretty much everything you might want on a tiny little bit of silicon. It's not designed to be very powerful or very fast usually, but they are very low cost and they're very reliable. Because you can kind of use them in place of kind of more complex analog hardware, you can design things a lot more quickly, a lot more easily, a lot more cheaply. And it means they're basically everywhere. So pretty much anything with a sort of tactile button on probably has a microcontroller in. You know, bike lights that cycle through various options, your wireless doorbell, infrared remote controls, all kinds of things will have them in. So why do you care about them? Well, if you're doing stuff on your own, it's fun to make things, even if it's just assembling flat pack furniture. There's kind of, it's good to have made something bigger than the sum of its parts. But doing that with electronics is sometimes a bit thankless. Once you get past a bulb and a battery, you can put things the wrong way around, you can blow them up, you can make them smoke. Often, bad things happen, and at the end of the day, you don't end up with something that's spectacular. But if you're doing that with a computer involved, you can do some really exciting things really quickly just by tweaking the software. And so, until about 10, 15 years ago, you had this. This was the parallel port on your computer. Every PC had one. You could plug pretty much whatever you wanted into it, and you got a sort of 3.3 volt signal out of it on several I/O lines. Pretty much any programming language under DOS could access it with no library, with about a line of code. It's really nice and easy for hacking things up. But now technology's moved on, and you've got this. You've got USB, and that's about it. So you actually now you need something else to sit in between, and that's microcontrollers. And for most people, it's an Arduino. So you've got this, which has got a little USB interface on it there, and then the actual microcontroller here. And if you want to turn a light on with it, then if you want to turn a light on from your computer with it, you've got to put a bit of software on there that will kind of interpret signals from your computer. You've got to write code on your computer to send the signals, and you've got to have kind of established a protocol to do it. At the moment there's Fermata, which is one that does kind of a whole bunch of different stuff like that, and it's used by Johnny Five and other things that you might have heard of. But it is kind of a bit long-winded, and actually understanding how everything works is really painful. So another option is actually to, instead of putting a Fermata for this interpreter, which is a protocol on the microcontroller, you could put an interpreter for a whole language, so you can do kind of much more interesting things. So this is one of the little Espruino boards, and it's basically the same thing. It's got a microcontroller on there that connects to the USB. It's got some I/O and a power supply. So if I take this and plug it in, I'm not going to show this very well, but if we just go to a console, and I just use a standard terminal app, so Minicom on Linux, or you can use Screen on Mac, or Putty on Windows, or Hyperterminal if you've got XP or something. So here you've got a connection to the device itself. I can type stuff in, and it'll be executed, and the result will be returned actually running on here. I can issue it commands that are kind of Arduino style. So if I say digital write, it's got a kind of command complete in it. Yeah, sorry. Oops. Okay. So we can do this, and hopefully the light will light up. Now, this is all done by using kind of a normal terminal, but I'm just sending the characters. So actually, if you want to automate something from your computer, you can actually just use a command like echo and send it straight to the serial port, which will usually be a device in the file system. So if I do the same thing here, to turn it off, and then I just send it to the same port, hopefully it will turn off. And you know, you can do really simple things with this. So for instance, maybe you want to take the state of the last command. There's an environment variable in Bash, and also I think in Windows batch files, it tells you the state of the last command. The last command was okay, so it'll have just returned 0. But if I kind of issue some command that will actually create an error, then hopefully it will have set the error case variable, and when I run this again, it'll turn it on. So you can easily write something that will turn on signals outside, like you know, even just your build state is a really obvious one. One line of code, and you can suddenly have like a big traffic light that tells you when something's wrong. So, oops. Yeah, going back to this, you can do much more than that, and I'll come to it later. So the problem when you've actually when you're writing code onto something like this at the moment is it's a very one-way thing. The microcontrollers were originally really designed for industry, and kind of everyone's still kind of having a bit of a hangover from that. So the Arduino IDE's, you know, nice, simple, quite easy to get to use. Everything's kind of included in it, but it doesn't have debugging. And even other ones like Mbed are, you know, a very good, all C++, loads of like really nice IDE with multiple files and version control, but still no debugging. Because to actually get the debugging, you usually need kind of extra hardware, and most of the tool chains that have it tend to be quite bloated, probably not free. It's all quite difficult. So one way to get around it is to put the interpreter on up. So yeah, this is, I think, a little bit like when I was trying to write a web page using like really early technology, and I had a web server that would execute code, and I had no error log. All I could do is write code, upload it, see what happened on the web page. If I made some changes and in amongst one of them was a bug, I would just get a blank page out the end of it, and that's a bit like what developing on an Arduino is. And really, it should have died out by now. But you know, it's still in Arduino land. This is what you have to put up with. If you do something that stops working, you're basically backing out changes until it works again, and then putting in print statements to try and find out what went wrong, and slowly re-adding everything. And it's just not as much fun as it could be. But, you know, 30, 40 years ago, you had these computers, BBC Micro and ZX Spectrum and others, that they had about the same amount of computing power as you could get in a microcontroller for about $1 now. And they managed to have keyboards, they had displays, they had editors for basic programs that, you know, you could write. If there was an error, it might sometimes tell you, you know, what was going on, and you'd be able to fix it. And, you know, why can't we have something similar? And you kind of can. It just happens that until quite recently, most of the interpreters available were for basic code, which was kind of looking quite dated. There are some really good things about it. So, I mean, the obvious one is that there's no toolchain to install on your PC, so it's actually very multi-platform. It will run on basically anything that you can get a serial connection out of. You know, that includes mobile phones, all kinds of stuff. The code itself, you can tweak it and you can change it while it's running. And one of the things that that's often quite difficult with like microcontrollers that you cross-compile for is that suppose you've made a project with one, you've put it aside. 6 months later, you want to change one tiny little thing. You've then got to find out the code that you put on that and make sure it was the right version. And you've probably got to get the right version of the toolchain, depending kind of what you used on it. It might be that your code doesn't compile with the new version of the toolchain, or compiles slightly differently, and that's too fast for hardware that you've got connected, or it doesn't run in some random way. It's quite difficult to actually get all that back. But if you've got an interpreter with the source code running on your device, it's dead easy. You just log in, your source code's there, the toolchain is the same version that it was always running on, and you can just tweak something, save it, and you're good to go. And a really big one is you end up with stack traces instead of seg faults when things go wrong, which suddenly makes stuff a lot easier to track down. So I thought I'd try and do a slightly more basic demo. So with this, there's lots of support for displays and Wi-Fi and various other things, but often quite fun things to do are just really simple things. So I saw a really simple nightlight that all it did was when you shook it, it turned on. When you shook it again, it turned off. Now it's something that you could do with kind of just normal electronics, sort of analog electronics, but it's actually ridiculously easy to do with a microcontroller, and it means that you can do some more interesting things with it as well. So if I take this and plug it in, all I've done here is, let's see if this works. Okay, so let's get it working. Okay, so this is like a standard little Espruino Pico board. It's got I've soldered a little power connector onto the back of it so I can show it running off a battery later. And I've literally just got a socket that I've wired a little vibration sensor onto, which is literally a spring with a wire running down the middle of it, and an LED. So I can just take this and plug it in, hopefully. If I can trap this properly. Okay, so if I log in here, this is the Web IDE. It's a Chrome web app, so it's just JavaScript, CSS, HTML, and when you install something from the Chrome Web Store, you can give it privileges needed to access a serial port. So it just gives you a kind of slightly more friendly way to access stuff than you would have had before with the terminal. So we can do the usual stuff with this. We have a pin that we have called B3 that we've connected the light to. So if I turn that on, obviously, hopefully see it lighting up. We can use digital read, another kind of Arduino style command to. At the moment, we'll just read the state of the button that's on the board. So it's not pressed now. It's not. If I do that again with it pressed, it will be 1. So simple things. You could write a simple loop that just repeated over and over, and assigned the value of digital read to digital write and turned the light on and off. But that's not actually very efficient. And as JavaScript developers, the obvious thing is to have it event based. So there's hardware on the chip that detects when things change state. So the whole chip can kind of go to sleep until it detects that something's different, and then it'll wake up and do something else. So, for instance, we can use this to make the light up or not. So if I do this, and yeah. And then we have to tell it that we always want to repeat this rather than it just happening once. So now, hopefully, when I press this button, it'll light up or not. So now we can want to do something maybe with the vibration sensor. So the vibration sensor is it's basically a switch. It's when it kind of things move around inside, it makes contact for a fraction of a second. So, for instance, if I add a watch for that actually just prints out the value of what we're getting. Whenever this pin changes state, and it's attached to B4. Hopefully, at the moment, nothing will happen because it's not vibrating, and also because the other side of the switch isn't connected to anything. So, when the switch hasn't made contact, the pin is just floating, and it will probably stay at the last state. So we can turn on a little internal resistor. which will pull it down. And now, if I move this, you'll see that a massive amount of events come in, which are basically this spring moving around and hitting and moving away from the little contact inside it. So, if we want to do this light that turns on and turns off, all we want to do is we want to react to the very first event, and we want to ignore all the rest of them. So, at the moment, we can dump the current state of the code that's in here, and it's just a lot nicer to develop in an editor rather than develop everything in a REPL. So when I say this, it'll actually try and reconstruct everything that it had in memory, which is why it looks a little bit different to how I typed it in, but hopefully not too much. So if I take all that, put that in here, get rid of that which we don't want, and we don't really care about the button anymore either. So now all we want to do is we'll basically, when we get a signal, we'll start a timer, and we'll call a function to say that this thing's been shaken, and we won't do anything until the timer expires. So just have a timer. We'll if the timer's actually active, we'll return, and we'll call a function when it's not active, and hopefully set a timer. So now if we make a function called go, hopefully, so now every time that function is called, it will just change the value of state, and it will write to B3, which was our light. So upload this, the light's lit up, and if I shake it, hopefully, pretty much every vibration it'll change. But now, we can actually, this is like a really simple thing, but we can start to do more interesting things with it. So we can maybe cycle through states with it. So if I go here, actually trying to change the code while it's still running maybe. So we'll just make it go between kind of 0 and 4. Well, actually, sorry, 0 and 3. Okay, so if we do now for the moment, I'll just leave that where it is. So if you can see that, at the moment we're only doing things for state 0 and state 3. One of the things we can do with this is we can create a pulse width modulated output. So this is basically, the outputs on this board can only give you 0 or 3.3 volts. So if you want to have something that's lit slightly dimly, you can maybe turn the output on for 10% of the time. So there's this thing called analog write, and if I just set it to 0.1, that would be 10%, and hopefully you'll see it's still on, but it's kind of quite dim. You can dim it down a bit more. So we can actually just go back up, and we can put this in for a few different values. Okay, so now, as you're shaking through, hopefully you see it goes through various different values, and you can do even more. You can make it maybe act more like a max sleep light or something, just by having a set interval that feeds this thing with a sine wave. But now you've actually got it as you want, you can just hit save, and this is all saved into flash memory. So if I now take this and unplug it, and I try and jam a power connector into it, So as you can see, it's completely standalone, but it's still doing exactly the same thing. So this will, because it's actually event-based, this code will actually use very little power when it's not doing anything. But actually, if I plug this back in, we can do one last thing that will make it really, really power efficient, which is to enable something called deep sleep. And you can't enable that normally if you're using analog write, because analog write uses the high-speed oscillator of the chip. So if that turns off when the chip doesn't think it's doing much, then it won't stay kind of half lit. It'll either be on or either be off. So we'll just do set deep sleep only when the state is naught, so only when the light's off. Saved again. And now this chip will be drawing, when the light's off, it'll be drawing kind of 0.03 milliamps. So this tiny little battery, it'll last for absolutely months. And, this is something that you could just pack up or fit with a non-rechargeable battery if you wanted, because it's really not going to be a problem. So why wouldn't you do something like that with something like a Raspberry Pi? Well, the main one really is that power consumption. The Raspberry Pi Zero is by far the most power efficient one. And if you change some settings and specifically power off the output, power off the power LED, you can get it down to what it seems to be about 60 milliamps, which is pretty good going. But something like the one at the top, if you imagine the B version of that with Ethernet, with the display controller, with the keyboard plugged in, you could easily be looking at sort of even as much as 400 milliamps for it. So this brings to why would you actually want to use JavaScript in this? On a Raspberry Pi you could use lots of different languages. And it's a bit ugly, but in a way an awful lot of people are used to programming in languages that look like JavaScript, like C, like PHP, like Java. It's a very familiar thing. But a lot of people know JavaScript already, and if you don't know it, you can learn it online really easily. And one of the nice things is that it does come with maps, objects, strings built in one way that works and that everyone uses. If you're using something like C++, you might well find that if you're pulling in different projects, some of them will use C strings, some of them will use wide character strings, some of them will use standard library strings. So it's nice and easy to get started with. You kind of know what you're dealing with, and having JSON built into the language when you're dealing with lots of different types of devices and in changing data between them is really, really useful. So I think this is one of the really cool things about JavaScript at the moment, is that it does come pre-installed in a usable form on basically everything. So while I'm sure most of the applications are written in C or C++ or Objective-C in the actual operating system, no one really exposes that for you because it's not sandboxed. So generally, actually getting access to a C compiler is quite difficult on a lot of platforms. But you can write JavaScript code and execute it on pretty much every device. It means that if you're writing a system that maybe you're logging some data, you're sending it over the internet to a server, and then you're letting someone access that from a mobile device, all of those devices will be running JavaScript in some form. So if you've got some algorithm that takes the data and kind of gives you some answer, you can choose whether you want to do that on the microcontroller sensor to kind of trade off bandwidth, or whether you want to move it onto the server to trade battery power, or maybe you want to let people tweak some values and actually do it quickly and get fast responses by running it on their device itself. And you can do that without rewriting the algorithm. It's always in JavaScript. So the other really nice thing about it is events, which I've covered a bit before. The interpreter can put itself to sleep when it knows it's not doing anything. It's a lot like interrupt-based programming, but if you're using interrupts on microcontrollers, you can get into a lot of trouble quite easily. It's very difficult to test what will happen to your project if your code is preempted at every single point that it could possibly be in, and a lot of bugs creep in. If you just make very, very small functions that are executed as and when they're needed, you get a certain level of multitasking kind of for free. It means that you don't need a separate execution stack for each process, and everything can just work really nicely. The REPL that you saw, where you could enter commands in, is kind of running alongside everything else in the system, but without proper multitasking. It's just able to do it because all the tasks just kind of leave when they're done and schedule a function to be executed for the next part of them. So just going back to power consumption again. So yeah, the Raspberry Pi, sort of 60 to, if you're like really got a lot of stuff plugged in, probably Wi-Fi pushes it up to 450, but it can go down quite low. The Arduinos, the actual chips can be quite power efficient, but it's hard to program them to be in sleep mode and wake up at the right time. One of the reasons is they don't have a real-time clock properly built into them. But generally, just trying to do all that and set everything up so that it wakes up at the correct time is quite difficult. The Arduino boards are not really designed for low power at all, and they generally use voltage regulators that are designed to power kind of quite beefy devices. But because they're designed to produce a lot of power, when no power is being drawn, they're actually quite inefficient. Sort of by contrast, the Espruino actually draws quite a lot of power when it's busy, but when it's idle, which is basically all the time apart from when it's executing a JavaScript function, it's really not drawing that much power at all. And when it's in deep sleep, it's drawing a really tiny amount of power. So a lot of people have kind of generally asked, why wouldn't you use a normal JavaScript engine and run it on a microcontroller? And really, it's just they're very different computers. You know, you've got about 1 million times less RAM. I mean, these are kind of picked out of the air, but they've kind of a rough idea of the order of magnitude that things are. But it's kind of quite interesting that you've got 1 million times less RAM, 10 million less storage, but actually there's not that much different in processing power. It's, it's, what is that? Yeah, it's not a lot anyway. So it's kind of weird that you can, on the PC it takes quite a lot of time really to read everything in RAM, but on the microcontroller you can do it all in a millisecond. So if you're trying to get like a nice balanced system, you probably want to be spending more of your CPU time trying to make the most of your available memory. It doesn't do you much good having really, really good performance in your 72 megahertz if you run out of memory really quickly and you can't do what you want to do. So this is an old picture, but Espruino, the software is kind of designed to make it easy to use a whole bunch of different hardware. There are at least twice as many boards as this now, and most of them available really cheaply. So, like, these are all subsidised by ST and available for, I think, around £7, probably a bit less, some of them, from places like Farnell. So you can just load Espruino on, and you can start working with that straight away. A while ago, I did this, which I kickstarted. It's pretty much one of those boards, just simplified a bit, but with all the code pre-installed, so you don't have to worry about trying to flash code onto it. And while I've been doing that, people have these white ones specifically, the embed-enabled ones, actually appear as a flash drive, and you can write the firmware straight onto them. So actually, it's quite easy. But these guys would require lots of drivers, lots of software to actually be able to write the firmware on, and it was a real pain. Even so, this guy and this one, which I kickstarted about 18 months ago, I think, they're kind of nice, easy to get started with. This plugs kind of straight into breadboard if you want to do it, so you can get running quite quickly. I did a really, really simple demo, which is kind of a little bit boring, but there's a whole bunch of different stuff you can actually plug into this. I mean, this again is like a really old picture, but people are contributing drivers for new things pretty much every week, and all of them are documented, all of them are kind of nice and easy to use. So kind of where I'm heading with it, this is a little Wi-Fi module that is kind of really quite nice and tidy, and I did actually make these little adapters. If people have got Espruinos and they've tried to use them, they know it's it's a little bit fiddly to actually get them all soldered on and get them put together. So at some point in the next few months, hopefully I'll be kind of doing a board that's got everything on it already soldered, and you can just get it, plug it in. There's things like this that I'll probably be doing little kits. There's a school in Derby at the moment that's using these guys, tiny little robots using model aircraft servos, and an Espruino Pico that you can actually program with a graphical editor. If I pop up here, you can on this side of it, you can do like a simple, drag and drop graphics programming. And there are like various robot related functions. So it's kind of a nice, easy way to learn, and a good progression really if you want to try and move from that to JavaScript. You can do it kind of with exactly the same system rather than having to move to something completely different. There is now a version of Espruino for the BBC microbit, so if any of you have kids in Year 7 that are hopefully going to get them in the next few months, it's worth kind of trying the software on it. Not only can you run it with the Web IDE, but there's a version of the Web IDE that runs just on a completely standard website, and if you have a Chromebook or a new-ish Android device that's either Android 5 and will run the kind of Chrome development branch, or Android 6 will do it straight off, you can actually get like full access to this wirelessly to program it. Exactly the same IDE, but that you can access just this website. Nordic do a whole bunch of different things. Nordic provided the chip for this, but this chip is in loads of different stuff. Smartwatches, it's in all these little Bluetooth tags that cost just a few dollars. So hopefully it's kind of quite exciting to have some builds available for that, to have a little device that you can just, you can put anywhere, that will last months or a year on a battery, and that you can program in JavaScript. You can put them around your house to detect when you open and close doors, or detect water levels or temperatures in all the rooms, and do whatever you want based on it. And these two up here they're these ESP8266 Wi-Fi modules, which, while you can solder them onto the back of the Pico to give you Wi-Fi, some people have put a lot of time in the community and have actually ported the software so it will run on that board. So this board that costs about $3 is now capable of running JavaScript with a web server, client. You can actually even telnet into it and program it and debug it through that. So yeah, lots of fun stuff. I've just got a little bit of time, so I'll quickly show you. If I plug this back in and I upload this code that I had before. Okay, so actually, unfortunately there's still no nice way to fit breakpoints in here, but if you just type the keyword debugger, then it will automatically go into a kind of debugging mode. And the nice thing is that it's done when it executes. So for instance, I can say, if I want to see, I can say if state equals 2 maybe. So if I upload this now, hopefully, when I do this a few times, it will hit the debugger. You can actually go in, you can see the values of your variables, you can step through, and it's like a proper debugger. But this is done without any extra hardware. This can be done on the microbit, for instance, just completely wirelessly, wherever it is. So from that point of view, it's kind of quite an exciting thing. I don't think very much else offers you that at the moment. But yeah, I think that's probably about me done. So, any questions?